Hi, we're going to talk about the fundamental counting principle. What it is a rule that allows us to calculate the total number of possible outcomes in a given situation. So let's start some basic problems. A dinner consists of a main course and a dessert. There are 4 main courses and 3 desserts to choose from. How many different dinner options are available? Well, one way to look at that, you have main course 1, main course 2, main course 3, main course 4, and then dessert 1, dessert 2, dessert 3. So from each one here, you can go with one dessert, right? From each one here, you're gonna get combined with one dessert, etc., etc. It can get very busy, right? But the way we're going to do it, we simply multiply the number of options here, which is 4, by the number of options there, which is 3, and we're going to get 12, and that's going to be our answer. Okay. There are 3 roads from city A to city B, so city A, city B, and city C. 3 roads here, 1, 2, 3. 5 roads here, 1, 2, 3, 4, 5. And to get the answer here, we're simply going to do 3 times 5, which is going to give us 15 routes. And here it's 12 dinner options. Okay. Shoe Corporation sells 4 styles of shoes. Each style comes in green, red, black, white, or in rainbow colors, and they also come with or without laces. How many different shoes can they make? So what these things are saying is actually relevant. We have 4 styles of shoes. We have 1, 2, 3, 4, 5 color options. And we have with and without laces, that's 2 of those options. You multiply 4 times 5 times 2, it's going to give you 40. You roll 2 standard dice. How many possible outcomes are there? Well, each standard die has 6 outcomes, so 6 times 6 is going to be 36. Now we're getting to something a little more interesting. How many different 4-digit PIN codes can be made with digits 0 through 9 if digits can be repeated? Can be repeated. So from 0 to 9, that's 10 digits. So you have a 4-digit PIN code. This is how I often do it. So what I'm going to do is I'm going to say how many digits can go in the first position. 10. Second position, also 10. Third position, also 10. Fourth position, also 10. Because we can actually repeat digits. You will see in the next example how it's going to be different when you cannot. So 10 times 10 times 10 times 10 is 10,000. Which means you can make 10,000 different PIN codes. How many different 4-digit PIN code can be made with digits 0 through 9 when digits cannot be repeated? Well, let's see how that's going to be different. 1, 2, 3, 4. So for the first digit, you have a choice of any digit from 0 to 9. That means you're going to have 10. Since you already used one digit here and you cannot use it again, you are now only going to have how many digits left? 9. For the third place, you used one digit here, one digit here. Now you already used 2 digits. You're going to be left with only 8 digits to choose for the third position and 7 here, right? So now it's going to be 10 times 9 times 8 times 7, and that's going to give us 5,040. Okay, so this is an approach that I always use to explain these problems. It always helps to understand that you want to fill 4 positions and you just need to write the number of possibilities. You don't write what these possibilities are, you just write the number of possibilities for each position that you're trying to figure out number 4. Okay, Usernames in a particular network consist of 2 letters, should say consist of 2 letters followed by 3 digits. Repetition of letters and numbers are allowed. How many usernames are available? So let's look at that the same way. So we have 2 letters and 3 digits. How many digits? You have 10 digits, right? Well, hold on, we'll start with letters. In English alphabet there are 26 letters times 26 letters, and then followed by 3 digits that can be repeated. We already know it's 10 digits for each one. So all we need to do is multiply 26 by 26 by 10 by 10 by 10, and that's going to give us 676,000 usernames. Right? Now they're thinking of expanding the network and also increasing its security, so they reformatted the usernames. Now username is going to have to start with R or N. After that it's going to followed by 3 letters that can be repeated, but you cannot use R, N, or, and then it's going to be followed by 4 digits that can repeat. How many usernames do we have there? Well, it's really confusing at first. Let's figure it out. So the first letter followed by 3 more letters followed by 4 digits, right? So again, the first letter, that must be R or N, followed by 3 more letters and then followed by 4 digits. But now we need to figure out the correct combination here. So for the first letter you can only use R or N. That's 2 possibilities. For the second and third and fourth letter you can use any letter with repetition allowed, but you cannot use R, and, or. That's going to leave you with only 23 choices. And then followed by 4 digits that can repeat, so it's going to be 10 times 10 times 10 times 10. So multiply 2 by 23 by 23 by 23 by 10 by 10 by 10 by 10. And that's going to give us a pretty big number. That's going to give us, after we multiply all that, 243340000. So it's 243,340,000 usernames. Okay, and that's it.